Okay, so here's a parametric integration question. So we're asked to integrate this equation in terms of t, and we've got to show that it's equal to the integral given in the question. Right, so first thing, as it's a parametric integration, I need to do y dx by dt dt. So I'm going to take my x first and work out what dx by dt is. So I've got 8 sine squared t. So remember, this is the chain rule because I've basically got u squared. Okay, so u squared, I'm going to do 2u times the derivative of u. So dx by dt is going to be 2 times 8 sine t. So we've done our 2u, that's basically u being differentiated. Now the derivative of u is going to be cos t. So that's 16 sine t cos t. Right, okay, so now our integral, as we said, is y, which is 2 sine 2t plus 3 sine t, and we multiply that by our dx by dt, which was 16 sine t cos t dt. Right, now looking at what we want our equation to look like in the end, we've got to start doing something with this to put it into the right form. And the first thing that stands out to me is that I've got one term which has got 2t. So we want to get rid of that. So what I'm going to do, I'm going to use the identity that sine of 2t is equal to 2 sine t cos t. Right, so let's do that. So now I'm going to replace that 2 sine, that sine 2t, but there's 2 sine 2t. So that means that I'm going to have 4 sine t cos t. Okay, plus the 3 sine t, and I've still got to multiply this by 16 sine t cos t. Okay, right, so now I'm just going to expand the brackets out. Okay, so 4 times 16, I've got 64 sine squared t cos t, plus 3 times 16, I've got 48 sine squared t cos t dt. Right, so now looking at my target, I can see that I've already got 48 sine squared t cos t. So now I can leave that part alone. And I'm going to concentrate on the 64 sine squared t cos t on the left. Okay, now I want that to turn into 8 minus 8 cos 40. So let's think about how we get the 40. So if I want cos of 40, well, that's going to be a double angle. So that's equal to 1 minus 2 sine squared of 2t. Remember, this is a double angle formula, and I know that I've got sine and I want cos. Well, okay, but I don't have a 2t, but I know that sine of 2t is equal to 2 sine t cos t. So by extension, that means that sine squared of 2t, which basically is the thing that I want, is then equal to, if the left hand squared, the right hand squared. So that's basically 4 sine squared t cos squared t. And if we look back here, I've basically got 64 sine squared cos squared. So what I'm going to do is my cos keep this in red. My cos 4t is 1 minus 2 times this square. So that's going to be 8 sine squared t cos squared t. Right. And my 64 sine squared cos squared, 64 sine squared t cos squared t is actually the same thing as 8 times 8 sine squared t cos squared t. So when I replace that, that becomes 8 times 1 minus cos of 4t. Okay, from just basically from above, using that identity. When again, if we expand that out, that's 8 minus 8 cos 4t. And then that means now I can replace that left-hand side and I get an integral of 8 minus 8 cos 4t plus the part we already have, which is 48 sine squared t cos t dt, and that's what the question asked me for. Right, now it also says that I have to find what a is. What a is basically for our limits, because our limits were 0 to a. Okay, and we can see from the graph that we want to go from x equals 0 to x equals 4. So when x equals 4, that means that 4 is equal to 8 sine squared t. So therefore sine squared of t is equal to 1/2, and therefore t is equal to arc sine of the square root of 1/2. And that means that t is equal to pi over 4, and that is going to be our upper limit. So our limits are pi over 4 and 0. Okay, and then the second part, now we need to solve this. So my integral from pi over 4 to 0 of 8 minus 8 cos 4t plus 48 sine squared t cos t dt. Okay, so again, good, because basically everything's added together, and so therefore we can do them separately, which is good news. Right, so what do we get? 8, easy, 8t. 8 cos 4t, so remember basically we're going to divide by the 4, because this is like the ax, because if you think if we were differentiating to get this derivative, we would have multiplied by 4. So now that means I've got 8t minus 2 sine 4t plus the same thing, I've got sine squared. So I've got sine squared times cos. So that is f of x times the derivative of f of x. So that means that I'm going to add 1 to the power, and I'm going to have sine cubed of t. And again, when I do this, when I raise the power of 3, I'm going to divide the 48 by 3. So I get 16 sine cubed of t, and I've got to evaluate that from pi over 4 to 0. Okay, right, so let's start doing that. Okay, so I've got 8 pi over 4 minus 2 sine 4 times pi over 4 is just pi, plus 16 sine cubed of pi over 4. And we're going to subtract from that 8 times 0 minus 2 sine 0 plus 16 sine cubed of 0. Well, 8 times 0, 0. Sine of 0 is 0. And sine of 0 is 0. So that basically that whole bracket is going to be 0. So I'm just looking at the left-hand side now. So 8 times pi over 4, that gives me 2 pi. Sine of pi is also going to be 0. And I've got sine cubed of pi over 4, which is root 2 over 4 times 16. So that gives me 4 root 2. And that is the exact area for R.